So a linked list is a collection of nodes, and usually when we're creating a linked list, we have a class for the linked list, and then we have another data type that is the nodes of the list, and this is the visual of this would be an entire linked list, and each one of these individually would be a node. The linked list class has to have a head pointer that points to the first node in the list, and the nodes themselves have to have a pointer that can point to the next node in the list. So for example, if this is the first node, this would be the head, and then it would have a pointer to the next one. Like this, it would be accessing the same memory address. Then this would be the pointer to the next one, accessing that memory address. And then next would be null, because there's nothing next in the list. This is the basic setup of it in a code from class. This would be the node here where you would have your data information here as your int or string or whatever, and then the pointer to the next node in the list. And then this is an example of a linked list class. Here we have a head pointer, and there is also a tail pointer. The head pointer is mandatory, but the tail pointer is usually optional. And then a bunch of functions that are typically implemented. And when you're creating the class, in the class constructor, you want to set the head equal to a null pointer. But the basic functions in the linked list class are, the constructor, you have to initialize your head and tail pointers. You can add a node to the list either at the beginning, the end, or somewhere in the middle in some kind of position. The beginning is the easiest, and the other two require traversal. Delete, same thing. You can delete from the beginning, the end, or a position. We need a search function, so to find a specific location sometimes, just find that. And there's also usually some kind of print traversal to print out all of the information in the list. Typically when we're printing, we do a while loop while current is not equal to a null pointer, so that we can access the last node in the list. But typically for deleting or adding, we need to access the node right before where we want to add or delete, so we would use current equal next as a null pointer. And also an isEmpty function is typically pretty useful for implementing some of these other functions. The benefits are you can create a list of abstract data types, so you can have things like structures with a lot of complicated information in there. And we use dynamic memory to add and delete from the list, so you can make it as long of a list or as short of a list as you want. You could have nothing in the list. You don't need to initialize it if you don't want to. And the biggest disadvantages is that in order to add or delete or do any of those functions, we typically will have to traverse the entire, or you'll have to traverse the list up until the point that you want to access. So if it's head, it's super easy because it's the first position and we have the head pointer. But if it's something like the end or somewhere in the middle, it could take a really long time to access some of those positions if you have a list with a bunch of nodes in it. And also, when implementing the function, if you accidentally access a incorrect location, you can get a segmentation fault that might be difficult to debug if you can't figure out where it's coming from, which might take up some time. Okay. And for the implementation of the code, okay, so the node that I created is the car struct, and it has a string for the model name and an int for the price, and of course the pointer to the next node in the list. And then here's the head car, and set it equal to null pointer. And so this is my isEmpty function. It just returns true if there's no cars on the belt, and it returns false if there is something on the belt. Then the add a car to the end function, it takes in the model type and the price, and we have to first check if the list is empty, in which case we have to use this information to set head. Otherwise, we create a temporary car, fill it with the information that we were given, then we traverse to the end of the linked list, and then link the temporary car that we created to the end of our list. And then I can show that I did that. Here we go. Oh. Okay. There we have we added a Ford that's $500, and then I'll explain I have a print at the beginning function here. I'll do that. So same thing before. I use the check if it's empty, and then it'll print if there's not any cars. Otherwise, it'll print the model and price, and I could show that too. There, no cars. So that's the print at the beginning function. And then, sorry, give me a second. I also created a regular print function that will traverse the entire linked list, because it helped me debug some issues. So it's pretty similar to the print at the beginning, except you just go through the entire list until you reach the end. And so here I've added a bunch of cars, Ford, Honda, Tesla, Subaru, Ram, with increasing prices. And there we go, Ford, Honda, Tesla, Subaru, Ram. Okay, and then to delete the defective car, takes in the position from the end, and then I use a pass-by reference variable to save the information of the car that we're deleting. So first check if there's anything in it, then if there's nothing on the belt, then there's nothing to delete. And then we have a current pointer and a stopper pointer, which will help us access the number from the end. Here's a loop to space the stopper pointer however much it needs to be ahead of the current pointer. This is an implementation of an edge case where if we're deleting the head, we have to make sure that the head points to the next. You have to make sure the head points to the next item in the list. And then, so it will do that, and then return, and I can show that. And then, let's see. So since I have 5 items here, to delete the head, I would be deleting at position 5. Oh, I still have this print statement here. Okay, here we go. says we deleted Ford, which is our first one, which would be, the fifth from the end. And then it prints out what's left in the list, which is all of the other ones. And then, if we're deleting anything else that's not the head, we have to iterate the stopper until it reaches the end. I'm moving my hands. I realize there's not a camera. And then we have to save the information so that it can be accessed by the pass-by reference, and then set your, I don't know how to explain this without my hands. So the current pointer has to stop one before the position that we're actually deleting, and then we create a temporary pointer that accesses the information, and we'll save it and give it to the pass-by reference. And then we have to link our current pointer, which is one before the one we're deleting, to the one right after the one we're deleting, and then delete the temporary one there. And so let's delete, I'm gonna delete Subaru, it's second from the end. And there, it says delete Subaru. Now it still has Ford, Honda, Tesla, Ram. Okay, that's it.